This video goes over the concept of cause and effect. So usually the main reason why you want to do a correlational study or investigate two variables is to find evidence of a cause and effect relationship. A health researcher may wish to prove that even mild exercise reduces the risk of heart disease. Perhaps a chemical company developing an oil additive would like to demonstrate that it improves engine performance. In each of these examples, establishing a strong correlation between the variables is just the first step in determining whether one affects the other. So let's look at some variables that you might want to compare and list the type of correlation that you would expect to observe between the following pairs of variables. We're also going to list whether the correlation is due to a cause and effect. So one variable is causing the second or affecting the second, or from some other factor. So here are the two variables: hours spent practicing at a golf driving range and the golf driving distance. So probably the more you practice, the further you can drive the golf ball. So strong positive. And this is probably cause and effect. One variable does affect the other. Second one that we're going to look at is hours spent practicing at a golf driving range and your golf score. So now this is probably strong negative, right? As you get better, your golf score would go down. This would also be cause and effect. The third pair of variables that we have here are the size of the corn harvest, the size of the apple harvest. I mean, they're probably correlated because good growing seasons would probably generate a good harvest in multiple crops, but they're probably not a cause and effect relationship. They're probably determined by an external variable. Finally, we've got a score on a geometry test and a score on an algebra test. I mean, they're probably correlated. Often, if you do well in one type of math, you do well in another type, but it's not dependent on how you do in one class. A cause and effect relationship is where a change in X produces a change in Y. So relationships are sometimes clearly evident. So for example, increasing the height from which you drop an object increases its impact velocity. Similarly, increasing the speed of a production line increases the number of items produced each day. The second type of relationship that we're going to look at is a common cause factor. So a common cause factor is an external variable causes two variables to change the same way. So for example, snowy weather is the cause of both more car accidents and higher heating bills, but car accidents and higher heating bills are not a cause and effect relationship. And then the second one here is, suppose that a town finds its revenue from parking fees at the public beach each summer correlates with the local tomato harvest. It's probably unlikely that the cars at the beach have any effect on the tomato crop. Instead, the good weather is causing the tomatoes to grow well, which is one, and also causing an increase in the number of people that go to the beach. The next type of relationships that you can have is a reverse cause and effect relationship, where the dependent and independent variables are reversed in the process of establishing causality, we'll fit that in under there. For example, suppose that a researcher observes a positive linear correlation between the amount of coffee consumed by a group of medical students and their levels of anxiety. The researcher theorized that drinking coffee causes nervousness, but instead finds that nervous people are more likely to drink coffee. The next type of relationship is an accidental relationship, where a correlation exists without any causal relationship between variables. This is a dangerous one because people can make conclusions about causation solely based on correlation, which are entirely coincidental relationships. The last type of relationship that you should be familiar with is a presumed relationship. And this is where a correlation does not seem to be accidental, even though no cause and effect relationship or common cause factor is apparent. Common cause factor is apparent. For example, suppose you found a correlation between people's level of fitness and the number of adventure movies they watch. It seems logical that a physically fit person might prefer those types of movies, but it would be difficult to find a common cause or prove that one variable actually affects the other. That goes over 1, 2, 3, 4, 5 relationship types that you should be familiar with between variables